Hi, today we're going to be going over our new chapter, Chapter 9, Right Triangle Trigonometry. To start off the chapter, we're going to be talking about the Pythagorean Theorem. So to start off, what is a Pythagorean Theorem? The Pythagorean Theorem is basically this. C squared equals A squared plus B squared. C here is going to be our hypotenuse. And the hypotenuse is always going to be the longest side of a right triangle. So this side right over here. So our hypotenuse, the square of our hypotenuse is going to be equal to the sum of the squares of the lengths of the legs. Basically saying that this right here, A, B, these are the legs. And if we were to square these values and add them up together, it's going to equal the value of our hypotenuse squared. So let's go ahead and use this into practice. So for the first example, it says, find the value of x, then tell whether the side lengths form a Pythagorean triple. Basically, what a Pythagorean triple is just going to be three values that are just integers. So like in here, 3, 4, and 5, this would be considered a Pythagorean triple because all of the side lengths of the triangle are integers. So let's take a look at this value over here. So we see here our triangle, our legs here are 5 and 12, and then our hypotenuse is x. So let's go ahead and use our Pythagorean theorem to find out what this missing value of x is. So c here is going to be our hypotenuse. We don't know what c is, so we're just going to say x. So x squared equals, well, our a value doesn't really matter here. Just feel free to choose whichever one. I'm going to say 5, and then 5 squared plus our b value will be the other side, 12 squared. And then we're just going to solve for the variable x here. So the first thing that I want to do here is do x squared equals, well, 5 squared is 25, and 12 squared is going to be 144. And then let's go ahead and finish this off. X squared is going to equal to 25 plus 49 is 169. And if I wanted to isolate the variable x over here, we're going to divide, oh, sorry, not divide. We're going to square root both sides. Since the inverse of squaring something is square root, that's going to cancel each other out. So what are we left with? X equals the square root of 169 is plus or minus 13. But since this is distance, or like an actual distance can't be a negative value, right? So we're just gonna err to the side of 13. So x is going to be equal to 13 over here, which is going to be our Pythagorean triple. So 5, 12, and 13, since these are all integers, like whole numbers, then we can say that this is a Pythagorean triple, okay? Cool, let's try out the second one. Find the value of x, then tell whether the side lengths form a Pythagorean triple. Let's go ahead and do the same exact thing. So just remember that the Pythagorean theorem is c squared equals a squared plus b squared, or a squared plus b squared equals c squared. Let's write it like that, actually, just to give it a little bit of diversity here. Oh, my pen. Okay. So a squared plus b squared equals c squared. Let's go ahead and just substitute these values then. Our a value will be 7. Notice here, our b value, we don't have a value here. It's just going to be x squared, and that's what we're going to find out here. And then our hypotenuse is 14, so equals 14 squared. Okay, so 7 squared equals 49. We don't know what x is going to be yet. And then 14 squared, what is 14 squared going to be? 196? Oops. And let's isolate the variable here. To do that, we're going to subtract 49 on both sides. And what are we left with? We're left with x squared equals 196 minus 49. That's going to be 147. And then lastly, let's go ahead and square root both sides, so that way we isolate the variable x. So now x is going to equal the square root of 147. If I wanted to simplify this radical, 147 is going to break up into 49 and 3. 49 times 3 is going to give us 147. And then 49 breaks up into 7 and 7. So what is 147? Going to be x equals, well, we have a pair of 7s, so 7 root 3. So our missing value of x here is going to be the 7 root 3. So what are the side lengths? 7, 7 root 3, and 14. Since 7 root 3 is not an integer, then tell whether the side lengths form a Pythagorean triple. There is no Pythagorean triple. But we do know what the missing value of x is, which is 7 root 3. That's it. Okay, bye.